Now let's substitute parameters. We have 10 minus 10i2 plus 10i1 minus 6i2 minus 4i2 equals 0. If we should simplify this further, we have 10 minus plus 10i1 minus 10i2 minus 6i2 minus 4i2 equals 0. We have 10 plus 10i1 minus 20i2 equals 0. So we have 10i1 minus 20i2 equals minus 10. We should divide all through by 10. We have i1 minus 2i2 equals minus 1. So let's label this equation 2. Recall, we've already derived our equation 1 before now. So let's solve our equation 1 and equation 2 simultaneously. All we just need is to eliminate i2 by subtracting equation 2 from 1. So we have it to be 2i1. This will cancel out, which is equal to 3. So we have our i1 to be 3 all over 2, which is equal to 1.5 ampere. So let's substitute the value of i1 into any of the equation. Let's say equation 1. We have 3 times 1.5 minus 2i2 equals 2. So we have 4.5 minus 2i2 equals 2. We have minus 2i2 equals 2 minus 4.5. We have minus 2i2 equals minus 2.5. So i2 is simply minus 2.5 all over minus 2. We should compute this upon use on our calculator. We have our i2 to be 1.25 ampere. So we've gotten our branch current i1 to be equal to 1.5 ampere, and sorry, our mesh current rather, our mesh current i2 to be 1.25 ampere. So the next step, or the final step, is for us to determine our branch current. That's the last task. Now, like I said earlier, we cannot get the value for our branch current without solving for the mesh or loop current i1 and i2. This is our loop current. We just solve for i1 and i2. Why? This is the branch current i1, branch current i3, and branch current i2. The branch current i1 starts from this point here up to this point here. So these are branch current i1. Is simply the same thing as mesh current i1, which you have it to be 1.5 ampere. Now for i2, we have the branch current i2 to start from this point here, this node, and ends at this node. This is what they refer to the branch current here. So only the mesh current i2 is flowing from here, from this point down to this point. Only one mesh current is flowing there. So it's very simple to get our branch current there. We have i2 to be equal to small letter i2, which is the mesh current, as 1.25 ampere. But for the branch current in the middle, branch current i3, we have two currents flowing through the components in the middle. We have two currents, i1 and I2. The question is, the question now is, how do we get the value of our branch current I3? Is it going to be the sum of mesh current I1 and I2? Is it going to be the difference of mesh between the mesh current I1 and I2 in this form, or in this form? What is it going to be? If you look at this carefully, you see that the branch current I1 and the mesh current I3 are pointing in the same direction. So we have our I3 first of all to be plus I1. Now, this is in case of current. Now, I3 seems to be pointing in opposite direction as that of I3 is supposed to is pointing in opposite direction as that of I2. So we have minus I2 because I1 dominates in the same direction minus this current flowing through this mesh current flowing through the components in the middle in the opposite direction. So we have it to be 1. This correct. We have it to be 1.5 minus 1.25 ampere, which is equal to 0.25 ampere. So we have our final answer in this form. Our mesh current I1 to be equal to 1.5 ampere. Our mesh current I2 to be equal to 1.25 ampere. Y for the branch current I1 equals 1.5 ampere. I2 is 1.25 ampere. I3 equals 1.25 ampere. So these are our final answers. So thank you very much, as we call it a day.